Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, my name is Moshe Pritsker. I'm the CEO of JoVe, Journal Visualized Experiments. And I'm going to give you a short introduction. What is JoVe? Why do we need video journal in science? And then show you basically how it looks today. So our mission is to increase productivity in biomedical research. And in my opinion, and based on my experience, it's very low today. So this is a typical research work cycle. So a researcher gets grant money, they do some new research, they publish it. Then in order to learn this technology, another researcher is supposed to read the literature, let's say an article in Nature or Science, learn how this technology works and reproduce it. Typically it happens by reading material and methods section in these articles. So today this process works very weakly, very unproductively, meaning you read an article, you are scientist on the bench, you read an article, you try to reproduce it, doesn't work. Doesn't work 9 out of 10 cases. You try to do it again, doesn't work. Then what scientists typically do, they either try to do it again and again and again, wasting their grant money, taxpayer money, and their time, or they try to look for other scientists who can show them how to do this procedure. And typically, after shown, they know how to do it. So the first question asked, why text literature today does not work effectively? It's peer-reviewed, it's prestigious, it's coming from the top universities. And the second question is obviously why show works? Why does the visualization works? So text doesn't work because it cannot transfer all the small details that are important for doing specific experiment. In the lab, when you work in the lab, sometimes it's important how do you shake your cells, like that or like that. And even describing it in the text would be difficult and sounds like insignificant, and for reader it would be very difficult to give a correct interpretation to distinguish between this and that in the context of all the experimental details. But this small detail can cost 6 months of the researcher life, right? So the core of the problem is a current format of scientific publication. So this is an example of the first article, one of the first scientific articles published in 1665 by Royal Society. And when you think about the scientific article today, you will realize that things did not change much. So you have title, author names, abstract, introduction, and then a technical description full of technical jumbo mambo that sometimes even specialists in the field wouldn't understand. Okay, now we have our materials online. We have color figures. Do we need anything else? Can we improve it somehow? So to show you an example how can we improve, I put this segment from a science article published in one of the top scientific publications, a segment from Material and Methods, and it's describing a certain procedure in embryonic stem cell research. Just for sake of exercise, let's read it together, right? Position the metaphase spindle at 3 o'clock and hold it with holding pipette. Apply piezo pulses to penetrate the zona pellucida, etc., etc. It's in English for those of you who don't know, right? And it's okay if you don't know and don't understand it, but it's a problem for me because I have a PhD in this area of research. And more than understanding this, I'm supposed to take this text and reproduce it on my experimental bench. So, question, what does it say? How can it be used, right? And as I mentioned to you, the visualization solution today applied in the labs is, the solution typically applied in the labs is visualization. So on left hand, you have the same text. On right hand, you have a short video that shows you what is exactly described in that text. So we'll watch it shortly. It's very short. Hello? Okay, basically it doesn't show, but somehow video got disconnected. But basically you see here a ball and you see here a pipette, and that pipette will come to that ball and scoop something out of there. That's all. And all that is described there. So concepts in biology are very simple. You really can describe it in your hands. But somehow it all gets lost as it goes through today's filter of scientific publishing due to the current insufficient text-only format. So text doesn't work. What do we do? So once I was suffering from this problem back in Princeton while doing my PhD on embryonic stem cells, I realized that scientific articles should change. It should not be text anymore. Or it should be text, but it also has to have a video that exactly shows you how to do the experiment. It's very, in a sense, mimics what scientists do in the lab when they ask their colleagues to repeat experiment, to show them experiment. So we built JoVe. And JoVe is built in the format of traditional scientific journal with only one exception. It has a video that shows how the experiment is done, filmed in the original lab. So I will show you how it looks. So this is an article on isolation of specific stem cells from neural, from brain. And it comes from one of the top expert labs in this area, Arturo Alvarez Bua at UCSF. So let's watch how it looks. Do we have speakerphone here? Awesome. Can you hear this? Can we? All right. Oh, it's up.
Oh, it is?
Yeah, it's. Yeah. This thing, not really. Sorry, guys. Audio. It's here.
We prepare whole mounts of the lateral ventricle walls. These whole mounts can be used either fixed for immunostaining or as live preparations to analyze ependymal flow.
The whole mount technique that Saman is going to illustrate to you today was developed over the years in the lab and perfected to study the whole wall of the lateral ventricle, including the ependymal cell.
Sorry, what? Okay, basically, I was sorry, guys. I don't know what's happening here, but the audio system. Anything we can do here? Okay.
And the underlying germinal activity in the subventricular zone, where the neural stem cells lie.
Can you hear it?
It was originally developed by Fiona Dodge and then perfected by Hine Victorle and Kazu Sawamoto.
So each video begins
All of them are no longer in the lab.
To say who they are and what they're going to do. And then video it becomes an animation. An animation shows the concept of the experiment. In this specific case, it's isolation of specific subaerial brain. The next part of it is basically the experimental procedure.
Under the stereo microscope, use the fine forceps to dissect away the olfactory bulbs. Use a stab knife to divide the brain into its two hemispheres. Cut coronally at the posterior end of one hemisphere to expose the
It's all right. It's good for demonstration. Okay. So you basically have to believe here that our videos have voice. And that's basically the idea. The article is not okay. The article is not text anymore, but it has this video component filmed at the original lab, and it has a text component. And obviously, traditional text component, something similar to what you can find in Nature protocols, biotechniques, or any other methodology journal familiar to biologists. And obviously, learning from this is way easier than learning from this. Okay, and a few words more about JoVe, its acceptance. So it was very important. So this is a structure of the article I mentioned. So we have abstract, introduction, experimental procedure, and discussion of results. And it very much mimics the structure of traditional text article, just in video. Journal, we act as a journal. We have editorial board. We index in PubMed, in PubMed and Medline. And it was, all those of you who develop resources in the scientific world, you know how conservative and hard scientists are when it comes to adoption to new workflows, to new instruments. And we, to some degree, were able to break this resistance by positioning JoVe as a scientific journal. And once you become scientific journal, you have to comply with many regulations, which includes peer review, requirements for scientific quality, indexing in PubMed and Medline. So by now, our articles begin to be seen as articles, as real scientific articles, despite this, the new novel video component. They are cited in other journals. For example, this article was published in 2009. So far, it was cited 6 times in other journals. And they get lots of views on the website, way more than typical scientific articles. So this article was viewed more than 40,000 views by now. And we constantly get these happy feedbacks from users that basically shows us that what we do is correct. And for me, among these feedbacks, the most valuable one is the last one, because it comes from the student who actually do their experiments in their labs. And so this tells me what we do is probably correct. And this is, you can see the growth in our usage since we were founded at the end of 2006. Right now, we have about 250 unique visitors per month. And we have about 400 universities subscribed to JoVe. We publish 50 video articles per month. So it's growing. Thank you.